Today we're going to talk about AI, but in a slightly different way. We're going to talk about security agents when you apply them on Azion's distributed platform. But most importantly, we'll talk about how we can scale, bring in tools, and provide more resources for these AI agents to work as protectors and provide security for your application. Today, I'm not alone. I'm joined by Vitor Eltz to bring some excellent content about AI agents, security, web application protection, and most importantly, how we use Azion's highly distributed platform to implement all of these strategies. So I'm going to bring in Vitor, who shared all this content during an Azion webinar that was streamed on YouTube and on our LinkedIn as well.
Well, everyone, so good morning. It's a pleasure to be here sharing some knowledge, about the advancements that Azion's platform has made in recent years. So we expanded the platform significantly to support different types of workloads. And we've reached the point, where we can support and offer functionalities and capabilities, for us to be able to scale agents that are becoming increasingly necessary in our day-to-day work to complete repetitive tasks, to help us provide input for other teams. So more and more, we're seeing the importance of simplicity, practicality, and being able to deploy agents and scale them according to our needs. So the idea is that we're going to go over some of the challenges, right? So some of the challenges of AI, or currently, especially the inference part, the part about distance, the latency, so how much that is important. We'll talk a little about what AI agents are for people who may not be involved yet or want to discover, ways to improve their work, their day-to-day. We're going to talk a bit about MCP too, which is involved in AI agents a lot. But MCP by itself is a whole other can of worms, as they say, because there's really a lot of subject matter, a lot of knowledge, and a lot of innovation coming out around MCP. We'll talk a bit about the Azion platform, how I glue all these components together, and I do the observability, right? How I can test the observability of my agents. Well, so before LLMs, autonomous decisions were driven by fixed rules, set rules, where we had to train models in a much less, let's say, fancy, less luxurious than it is today. Oh, today I'm going to train a model. I'm going to make the model available. Of course, today there are tools, right? And much more technology than a while ago. So before it was much more complicated for me to give that autonomous behavior to the models that were being built to mount. And then after the Transformers paper was published, there was this revolution, right? In how I could refine, create, tune models, whether with a lot of information, many data sources, or few data sources. And today, LLMs are, well, today, let's say, much of what's driving innovation and technology came because of these models, right? The large language models that are available. Several companies out there, you've probably already used them: ChatGPT, OpenAI, Gemini, then Anthropic with Claude. So there are several companies with gigantic models and important open source models. But that's it. After LLMs, a range of possibilities opened up, and it lowered some barriers that before were much more difficult. Or they were barriers where we tried to frame things like, oh, the person who has their own business, the entrepreneur, they often won't be able to, say, develop a website. And today they can. They have ways and means to launch their site, to create their own site, literally by writing, by speaking. So it is a revolution, right? And for me to be able to do this deployment, I need to have an infrastructure available, right? An infrastructure that is really prepared for these types of applications. building applications is getting more and more complicated, right? So, how do I manage to get maximum performance, maximum uptime and availability, the lowest possible latency, and be as distributed as possible? I want to provide an application exclusively for a specific country. I want to have an infrastructure that supports me there. So, really, for us to be able to do that, right? Applications are getting more complex. So, it's really not easy. So we need to configure various components. We need platforms and providers that can serve us in many different ways, right? And that really, on top of everything, right, has an attractive cost benefit. So really, it's getting more complex. Applications are complex to build in the sense that there are many details. There are many concerns. For example, as we say in the world of security, sometimes the developer has to worry about more than 100 routes to protect, to provide security. And sometimes just one route is enough for an attacker to do absurd damage. So really, it's something that is complex and meticulous. What we try to do is remove that complexity to bring components that are already practical so that we can really remove that complexity from the applications themselves, right? And make it so that often one team can have the autonomy to take care of various components of this application, right? To really have ownership of that application. And because it's complex, right? We have types of training, types of workloads involved in AI, applications involving AI, involving agents. You have the training part of these models, which you've probably also heard a lot about. Oh, OpenAI is releasing a model that was trained with, I don't know, the entire internet that already exists. Google trained with N results and retrains with XYZ data. So that's one part that happens, right? Which is a difficult part. It's a part that requires, right? It's now the race, right, for energy. So more and more companies are creating data centers to be able to make these trainings bigger and bigger to support more parameters, to support more information, right? And after having this trained model, I need to have its inference process. So I need what is inference? It's me requesting, consuming this model that will be made available somewhere. It will be executed on some specific infrastructure, a specific region, a specific position. It will be consumed. So I also have to worry not just about the model I use, the trained model, but knowing, oh, I'm using a specific model for code generation. I'm choosing a specific model for image generation, a VLM. And I'm also concerned about the inference part. Where am I performing this inference? How long is it acceptable for my user to wait for the response from my AI application to come back, right? How much time, this latency, is acceptable for my user to wait? So all of this is important because it's not just that the technology is cool, having a chatbot, having a copilot, but if you end up frustrating your users because of a delay in the response, or because many times the model is not working, we had problems recently with Google, with Gemini. They went through difficulties with the inference part. So sometimes it worked, sometimes it didn't. The model itself would give an error. The infrastructure, right, was having some difficulty. So when that happens, we can't just rely on one player. We can't just rely on one provider. We have to diversify and also be concerned. Be concerned with the experience that our user is getting, right? So distance today, it's not so much about the technology now making the model available, but often it's this part of inference, right? Distance and speed have a direct impact. And we know that the main providers are cloud providers, right? Aside from OpenAI, but OpenAI is under Microsoft, so and they also use AWS. So I believe that we have several players using large data centers. But there are other providers, other platforms that were also created with the intention of distributing this workload more. That saw that really, right? Companies like Azion identified that there's a gap between me being able to perform an inference and request an image that's being processed in the United States, right? I'm here in Brazil and it's being processed over in the United States. That's going to take a while. It takes time. It's the same computational difficulty we had years ago with on-premises infrastructures, with large e-commerce applications, maximizing that response, maximizing right that return, me requesting a page and having it returned to me right away. So the user wants that. They want a good experience. They want to make a request and be surprised. A quick image here and quickly it's already returned. The model has already responded with that image. So it's a different impact than a larger model, a model that's far from me, from where the user who is making the request is. And this impacts them, right? It impacts the usability. It often decides what will be done. Many times it's decided whether a specific fine tuning will be done to reduce the model's size. So there are several techniques, but today one of the biggest challenges is distance and speed, right? So uh, being, as I said, being closer, right, to where it's being executed and in this model, right, or rather in the infrastructure is much more beneficial for me. And that's what Azion brings, an infrastructure ready for this. Not only with all the hardware that we take care of, right, that we dedicate ourselves to implementing, but also with GPUs, with powerful GPUs to be able to serve these applications, these models that will be executed and where the inference will be done closer to the user, right? So it's an evolution, right, of a platform that is we are very well known for being excellent in security, cache, several functionalities, right? But we also have pillars, right, that are growing, that are becoming better and better, right, for the applications for our users today, right? Inference, right, is where companies will spend most of their budget, right, of their financial resources. So you have these options. You can put it in the cloud on premises, where you'll have some advantages, you'll have other disadvantages. So it all depends on your use case. But in the main benefits, in the main points, for me to be able to have better performance, lower latency, and be able to easily scale these applications. With AI is I'm going to try to choose a platform that can provide me with that can, especially where I'm based, right? So we see many companies are already creating applications, right? We talk to many companies, they're already creating applications. But these are applications, but they are applications that are running overseas, a lot because of the cost barrier, a lot because of the geographical issue. But is today we see that there isn't that much of a need. There are other platforms like Azion that can meet these needs, right, in a distributed way, in a simplified way, in the same way that you will get service or will have these resources within a cloud provider, right? At this moment, right, with distributed infrastructure, it's never been so easy to build an application and scale an application using AI as it is today. So we see this firsthand. We just had a hackathon internally with our teams, and several very cool solutions came out of it. And we see it both internally, we're using our own platform, doing dog fooding, as well as we see it in other companies, right? In other partners who are using the platform and who are benefiting, from building these applications with us. So today, it's never been so easy for, say, a marketing team to have an agent, to have a chat bot, to have a knowledge center as it is today. Again, there are countless use cases that we can automate with these agents, that we can execute within the platform, that are for teams that often aren't even technical. But these teams, I guarantee that these teams can upload an image. They can, in the same way they interact with other applications, they can converse. So it's about providing the same experience that people are already used to having in their daily lives and bringing that to the benefit of being able to build these applications easily, to provide these applications easily to that person. Azion, it comes with this platform that not only delivers incredible performance in terms of cache and security, but we can also deliver not just a single component, but rather an entire comprehensive suite, a whole runtime environment that is fully capable of executing a wide variety of applications and models. It can perform advanced inference tasks, and I can build very specific and customized functions with which I can further enrich and enhance my AI application. Additionally, I can also deploy MCPs, or model control points, as needed. This flexibility allows for a much broader range of possibilities and use cases within the AI ecosystem. So it's very cool how a platform gives us the options for us to be able to reach our objective. And Azion, as I'm going to demonstrate with some components, manages to provide this in a very cool way. So one of the products that I want to talk about, right, that allows this is functions. It's the one that it's the product that has a runtime. That is extremely high performing. I can execute JavaScript functions. I can execute functions in other languages in a much more in a distributed way. Meaning, just here in Latin America, I have more than 60 points of presence. We have more than 60 points of presence. So imagine I can run a function that will be available to be invoked in a completely distributed way. So a user who, for example, is using a conversational AI agent and is using functions under the hood will benefit because they'll be communicating with the node that's much closer to them rather than a node that's farther away, geographically speaking. So through this runtime that can identify these requests and handle all the load balancing and direct that entire workload to where it's most requested, closest to the user. So with functions, it's literally executing code. I can create entire applications. I can run frameworks. I can create, these have these inferences. We developed specific functions and methods that can interact, with our engine, our inference runtime that communicates with the GPUs. So it's a product that allows exactly that. I can have automatic scaling. I can have high availability because I don't need to provision how much memory, how much processor, how much storage I need in that container in that VM. No, it's a runtime that doesn't have any container. It has no abstraction. It's really an engine that many are already running. They already know it, which is V8 isolates. And through this engine, we were able to develop a whole layer of APIs, right, and methods, where Azion leverages all that power of speed and performance to be able to execute these JavaScript applications, right? And I say JavaScript applications but it's one of the languages we support natively, right? But also because a lot of the innovation in this AI sector is also centered around JavaScript and Python. So there's a large ecosystem being created around the language. So today I have several possibilities, as I'm going to show in our webinar, right? And another extremely important component is storage. Where am I going to keep this data? Where am I going to make this data available? So within Azion, I have some important components like object storage, which allows me to handle all of the. It has the function of being my object storage, where I'm going to store, for example, all the images I want my model to use, all my PDFs, context, basically all this raw data that I will later subsequently use as a reference, as context for my AI, right? So I'm going to enrich my model with these objects that will be queried and used by these applications within object storage. And we have SQL Database, which is very important because it has the specific capability to become a vector database, to have vector search functionality where I can perform this vector search and deliver to the model, right? Do this basically fetch these references, search for this information directly in the distributed vector database. In other words, that's another benefit. Not only do I have a runtime that's already distributed and will execute the code, but I also have a distributed database. Because many of these, many agents, they have knowledge saved, stored. This knowledge needs to be in some place. It will go through some process, some database with this vector database capability. However, many options on the market are centralized. They don't operate in the same way as our SQL database product, which is truly completely serverless and distributed. This means I have all the reads, all my tables, replicas, my database, they reside on each node in Azion's distributed infrastructure. So speaking of Latin America, with more than 60 nodes here, I have a replica of my database distributed uh, natively, right? So I can have the entire inference part, the function, the code, and the data storage side by side. So this is really, it's a performance gain that we see in applications. It's staggering, right? And we're coming out with a product that's fresh out of the oven, so to speak, which is our KV store, which will also be used for various use cases. We have some use cases that we see in the market. So the concept of KV store, of key value, is very important in this ecosystem because it will give me the flexibility, right, to store files and unstructured data, right, in a way with fast access, right, with a cache that's also available in a distributed way. So in other words, in addition to the products, functions, SQL database, object storage being distributed, I'll also have a distributed KV store, right? It will allow me to store this data that isn't structured, no SQL, in a much more high performance and efficient way. Really I want to make, say, a security agent that queries in real time a table a document, a table of IPs that is stored inside the key value. So I can give this type of power and autonomy to my agent for it to perform this check. To evaluate, hey, this IP that's coming through this application, through this route, does this IP make sense? Is it in this table? Is it in this location? Ah, it is. It isn't. So it can have the rules defined there for it to ensure whether the request can proceed or not, right? So the KV store really comes with this purpose of being a super fast database and also one where I can store unstructured data, right? So in a distributed way. So it's very cool. Like I'll be able to do all the caching to enrich my APIs, enrich MCPs that often have a specific context when they are executed. If I plug in a key value, I can basically create a memory for these models of mine, so they don't consume, for example, as many tokens as they could. So the advantage is huge. And as I said, it's fresh out of the oven. We're almost launching it for all our clients to be able to use. And the goal of these products I mentioned is for us to ultimately arrive at this architecture. The idea is for the user to make a request to my node, right? The closest one. This node is running the entire runtime, all the systems that the Azion platform uses. Inside, it's using functions, where this function is connected. It has bindings with the hardware, so it can access and process the code directly on a GPU. It can make that handoff. So inside my node, I have my runtime being controlled by my applications and communicating with resources and components, as I mentioned, like a distributed database with an embedding model, a BLM, or or it's plugged into a UI where I'll run the queries and do the chat. So it's a slightly more summarized diagram, but it's meant to convey this idea that with just a few components, I can have an agent that will be able to assist me, right? So what are agents, right? So it seems like I have it like this. I don't want to be too repetitive either. And to bring something that perhaps many already know, right? But basically, they are forms, let's say. They are resources, they are systems where I can, in a certain way, let me think in an unstructured way, but with a system of rules. I can, with a foundation, with a framework of tools, build an intelligence that can, through an LLM model, access and perform various tasks. I can create an agent to perform only one targeted task. I can do it. Working with an agent who is autonomous allows me to give them real-time autonomous actions, such as, for example, I want you to produce a report every X amount of time and deliver it to me. So he independently evaluates the conditions and I am able to deliver this report. I have human in the loop, right? So when the agent, I have human interference. That is, I am acting, whether with a co-pilot, an assistant, or when the agent is going to execute, the agent is in code, it is generating code and it wants to execute some command, access components there on your computer locally, and it cannot have that permission to do that. So it requests that approval, right, to continue with the processing. I can plug in a memory agent, just one agent that will retrieve my knowledge. So, for example, he's the marketing specialist for an XYZ company, meaning he'll know all about branding, he'll know all the information, how the pages are built, he knows the visual style. And let's say I want to use this agent for that purpose, to be my agent, to help me build new pages. So based on the knowledge generated, based on the knowledge he already possesses, I can generate new things through this memory that he has. I can plug in tools. So within the agent, I can plug in tools. Here I'm going to divide it up. There are two concepts of tools, two or more concepts of tools. He has the tools, which are the function calls there, are functions that are tools in a format. For example, I want to retrieve my temperature, the temperature of my city. It's a slightly different format for the toolkit I provide to the agent. And I have MCPs. And MCPs are a smarter way for me to give tools and powers to my agent. Because without a toolkit, my agent is basically just a layer on top of a model to provide responses. So in essence, it's basically like taking an open model or an entire language model and just plugging in a route, doing some routing so I can talk to it and extract that model's output. Without the toolkit, the agent is limited to acting as a simple intermediary with only basic capabilities, simply passing information back and forth between the user and the model, rather than performing more complex tasks or accessing external resources. The idea isn't that, right? Normally, I want to give specificity to my model. I want to make it specific. So I want this agent, sorry, I want this agent to have a specific tool that interacts with my APIs. Or I want a model that has an MTP with all the knowledge of how I can build. Open API schemas, or better yet, I have an agent that has all the knowledge of my request patterns and how I can identify incorrect patterns. So I can have an agent that has this type of knowledge with an MCP plugged in. So an agent, as I was saying, an agent by itself won't do much other than being an interface with a chat. You can enrich it and give it more autonomy so it can execute much longer tasks, right, in your day to day. So these are agents, right? So as I was saying, I can process and transform data. I can customize. I can create a hierarchy within agents. And the idea is that we can do this, and we can do it within Azion. So today we have some components that we can assemble and deploy these agents. Through a very well-known framework on the market, which is LangChain, and within LangChain, I have some capabilities, some functionalities that are almost like other products. But I have LangGraph, I have LangFlow, I have LangSmith, and what it basically is a framework that brings a lot. It's like a JavaScript framework that brings a lot of tools for front-end development. It's the same analogy for building agents. So it's a framework that gives me a simple way to build agents through this concept of graphs, where I connect. So I'm going to have my agent, and I'm connecting nodes of actions and interactions that my agent performs. So I'm plugging in a memory. I plug in specific knowledge. I create an orchestration routine with it. So I can do that plugin inside, inside this framework, which is LangGraph. I can plug in various tools, and deploy and execute them directly on Azion. So that's basically it. It's not just LangGraph. We have several other frameworks for agents that support it, TypeScript frameworks. But LangGraph is one of the biggest, one of the fastest evolving. So it's important for us to provide this support, right? So with it, I can automate various routines, right? What does Atheon do? It provides the means, the environment, the primitives, the web APIs. It provides the tooling for me to be able to take this code that I can produce with this framework and run it on a distributed infrastructure. Instead of me getting a virtual machine or running an entire agent, my code in a container, no. I run it on an infrastructure that will serve me in a much more performant and much better way. And so I'll tell you that it's much easier than often running an application in some container, having to create a container there, all the rules and so on. So it's often more practical to just run it on the Azion platform. And well, how can I do that, right? I'm going to share the Azion console there. So here on the console login, basically I'm here on the home screen, right? I have a create button, and here inside this create button, I have several templates I can work with, several templates. And these templates, there are framework ones, there are templates that Azion itself built and provides support for, right? And there's our template for an agent. So here, basically, I already have a whole set of tools that allows me to deploy a customized agent, right? So in other words, I have the agent's name. I bring my API here. In this template, I bring an API from OpenAI. You can often create it very easily there, your API key. You can bring your API key from OpenAI, and you can even edit the system prompt. For those who don't know the concept, the system prompt is like the base prompt that for every request, every inference the model makes, it will load that information. In other words, you'll say something like, you'll be an XYZ assistant that will have certain knowledge about and will perform a certain task. So here I can often even put, depending on the level of specificity, I can even put output formats that I want. Like, I want you to always bring a formata, a table, CSV, like this and that, right? So with the system prompt, it's basically the objective, right? The purpose of my agent. I can also handle publishing the authentication part, the authentication mode, creating the authentication mode. So it becomes much easier for me to build private agents where only my internal team can access, for example. We're also releasing a new template where it will be possible to plug in your OAuth. So it's more practical too, right? Plugging in the OAuth there. So with GitHub, I link my GitHub and do the whole deployment process here for my agent in a much more practical way than many platforms, where you have to choose the model there. You have to some configurations, right? So I already come out with a workload ready for me to execute my agent. So it's much more practical when we have a template to start with. Much easier, right? And I can also start and deploy MCPs, MCP templates. In other words, I can Soon, right? There will be more MCPs here from the Azion API. We're working on releasing these MCPs. But here we have an MCP, a template, a boilerplate from scratch that you can build there without authentication easily. I want to plug in a knowledge path. Or you can bring a bit of specificity to an agent. So I want to analyze all the HTTP events that go through Azion's real-time events, right? Which is the observability product. And I also want to be able to communicate with network lists. So I can have an MCP that my agent will be able to interact with much more practically, much better. Besides that, I'll be able to interact with resources and tools, right? And APIs that Azion itself provides. From the GraphQL API of real-time events with the HTTP events, I'll be consuming the network lists API. So it's basically an MCP that allows me to analyze events and have my model write to network lists that are already uh, being have blocking rules using Azion's firewall. These network lists are dynamic lists of IPs, right? That I can create within the platform, right? And I can trigger these network lists within Azion's firewall, where I say, this network list, this request, if it matches an IP on this list, do X, do Y, block it, put it in a rate limit. So I can grant this power of action without me, Vitor, needing to be acting or coding an entire system to do this. I can have the model act for me in this way. It becomes much more practical, right? And even talking a little bit about going along this line of MCPs, I wanted, I really wanted to bring up this point, right? That it's being a game changer, right, for the part of tools for LLMs. So, and especially companies that already companies that are serverless platforms that have distributed infrastructure, they are ahead of the curve. Because just for the fact, besides the geographical fact, right, it's because of the technology that many of these companies, right, like Azion, are providing much more easily, or even technologies that wouldn't need to be developed because the fact that it's distributed, that all the orchestration is already done by the platform. I worry much more about what tool my agent is consuming, what model my agent is consuming. So the idea is that we can publish these MCPs, create these MCPs in a very simplified way. So let me even pull up an example. But basically, what I wanted to show you was a part of the implementation code. But the model context protocol itself, they provide a whole client inspector, right, for you to use to test the development of your MCPs, right? So you can, of course, when you're developing an MCP for Azion, you're going to use the streamable HTTP, which is the transport protocol, the remote communication protocol. So it's through request and response, meaning I'll make a request to a server and wait for the response from that return of what my tool, what my MCP processed on my server. It's different from SSE and STDIO, which are protocols I can use for local communication, right? For my MCPs. So the idea is that I have a protocol I support where I can deploy tools in a way that allows me to reuse these tools in many different places. In other words, imagine a development team that deployed an MCP based on all its development documentation. And the team doesn't have a standard tool. Some use Cursor, others use Insurf. But you can through this published MCP. And with a security and authentication implementation, you can allow many different tools and clients to support this MCP. Here for you to see, right, in practice. Yes. Basically, this is the MCP. The MCP where we have the template to fetch query events, HTTP events, and the NCP for the network list smart. So basically, right, I was able to create a whole way for my LLM to interact with APIs, right, which is the MCP protocol. And I can give it the function to create network lists, list network lists, get network lists, do an update, for example, of network lists. And here it could be, for example, I want the rules engine API. And I want an MCP, an agent, to help me create rules within rules in the rules engine within Azion, or I want to use the fact that Azion supports, for example, functions that I can deploy applications. I want to plug this knowledge of Azion together with a code generation model where when this model finishes, it already outputs in the standard that Azion supports, for example, for applications, for JavaScript. So I have N ways to build and N use cases for building MCPs and agents, right? And the idea is that I can glue all of this together, right, in there, using the Azion platform, using the components, right? When I want to publish some storage, I have the storage part. When I want to integrate an API or create an MCP, I have the infrastructure and the platform to support the deployment of these MCPs. And I can scale, right, these my agents through these MCPs. So I can give uh, unique tasks, right, objective tasks to these agents. And a very important point is observability, right? After I've deployed this agent, how can I handle its observability? I have the prompts, I have the tools. There's the part of executing, whether it's code, executing APIs that my agent is using autonomously. But I want to understand its usage. How many tokens are being spent, for example, with this agent? So I want to have a bit more predictability, right, from this agent. So how do I do that, right? Within within the family, I'll mention the LangChain family from the open source project of frameworks for agents. They have an observability platform as well, which is LangSmith, where you can plug it in very simply within our code. We've already, especially in the templates, we've already set up an environment variable ready and available so that it's possible for you to plug in your LangSmith. So you bring your LangSmith API key and you can get access. And you get an observability toolset that gives you much more accuracy in knowing what's happening, where it is, which models and which platforms are being used. For example, I want to know how many tokens were spent, right? A total of 540 tokens on a question, for example, right? So I can know where it went, what was the document, right? For example, if I have a database plugged in, I want to know exactly what the line of reasoning was for the vector it searched for, right? To give me that answer. I want to know how much time, right, is being the latency it's taking to get a response. So with LangSmith, I can have a very large observability platform as well, with data that I can either use their own API to fetch and consolidate in another database, or I can use their own dashboard. So have a few ways, right? Some ways to consume it, but it's really a very complete platform for the data and observability part of agents. For the code part that these agents are using, for sure you have Azion itself. You have the Azion platform with the real-time events and real-time metrics products to handle the application's observability. So let's say I have my application, a route is now giving a 500 error that my agent consumes, right? And you'll see this error, right? Either through real-time events, evaluating its runtime errors, but for all the application parts you deploy, you have the entire observability component within the Azion platform, right? Or you can receive it the same way through data stream. This data that will allow you to receive it in your CM and your data platform and build dashboards as you need. To share a success story, which I think is interesting to mention, a case of success, right, that we wrote about recently, is with the company Axer, which created a very interesting use case. They already have, they are already a company specialized in threat detection, right? Intelligence and protection, with products there for protection and credit card leaks, which is very important for various e-commerce platforms. And they had this challenge of how to improve fraud detection, how to recognize it in real time. So it's a use case that absolutely needs performance that can really keep up. It needs a distributed infrastructure that will serve these thousands and millions of users, making requests, consuming, and making payments on platforms running Axer's software and service. And as part of the challenge, right? So we join them in this challenge of providing the platform for Oxer. And it's really been a success, right? Because besides being able to run workloads that are gigantic, right? It's really, I think it's 500, 450 million sites, websites that are verified by their fraud detection product. It's very important for us to deliver this high performance infrastructure to them and the entire the tool set for it, right? So it was a case, it's a success story, it's scaling more and more, right? So it's very interesting because we can also, on our side, understand the types of use. Among the clients we've talked to and the use cases we have, this is really a very massive use case. Also, something I didn't mention, they used the LoRa part, right, for low. It's it's low rank adaptation. So I can take a large model, an open model, for example, and do a training, right, a fine tuning on top of that model, right? So I can take this model and reduce it so that it becomes a specialist, in being a marketing assistant, for example. So it will have a certain knowledge. It won't need all the knowledge of how geography came to be on Earth. No, it's a model that will be trained, that has been reduced, and it will always be called through this fine tuning that is done on top of a larger model, right? So, and that's also supported within the Azion platform, right? That's something I hadn't mentioned, which is the support for LoRa. So models today that have that are open source and clients who already have these open source models and want to bring them to a distributed platform, we can also support them in that regard, So we were able to help Axer a lot, and we're still helping them, right? So it's a success story that I wanted to share so we can gauge a little what kinds of use cases we can bring into production, And that's it, everyone. I believe we'll be producing more content and we'll be able to create more videos to better illustrate and exemplify this scenario.
Tell me this content isn't incredible, right? So, hey, if you want to test all of this in your application, use the link in the description to create your Azion account. As soon as you create your account, you get $300 in credit. Then you can explore, test, bring over your applications, bring over your workloads, and experiment with everything that Vitor shared in this video today. If you still have any questions, leave them in the comments and I'll get Vitor to answer all of them for you, okay? So hey, I've left another related video here. Keep exploring, learning a little more about Azion. Click on it because this video is now over. Bye!